Hello and welcome to today's lesson on the turning effect of a force. In this lesson, we will begin by introducing turning or rotational effects of forces. We see these every day, such as when we open a door by pushing or pulling on it. This discussion will then naturally allow us to introduce the idea of a moment, which we will categorize and explain on an intuitive level. Finally, we will develop our understanding of moments, using some examples to understand this concept better. So far, we have delved into the basics of forces and how they affect the motion of objects. We have explored different types of forces, including friction, tension, gravitational forces, and air resistance, and understood their effects on linear motion. Building on this foundation, we can now explore how forces cause rotational motion. This lesson on moments will expand our understanding of how forces operate in different contexts, giving us a deeper insight into the principles of physics that govern both linear and rotational movements. Let's get started. The forces we've discussed so far have primarily been about moving objects in straight lines, whether forwards, backwards, or up and down. However, forces can also cause objects to rotate. This is another fundamental way that objects respond to forces. To illustrate, consider trying to open a door. If you push or pull on the door, you are applying a force. However, notice that the door doesn't just move straight. Instead, it rotates around its hinges. This rotating action is caused by your force being applied at a distance from the pivot point, the hinges. This rotating or twisting effect, generated by a force applied at a distance from a pivot or fulcrum, is known as the turning effect of a force or the moment of a force. Now let's talk about moments.
So, what is a moment?
A moment is what engineers and physicists call the rotational effect of a force. When you apply a force to an object at some distance from a pivot point, you create a moment. The moment depends on two main factors: the magnitude of the force applied and the distance from the pivot point at which the force is applied. This distance is often called the perpendicular distance because it is the shortest distance between the pivot point and the line of action of the force. We'll develop our understanding of this concept in our next lesson, where we dive into the mathematics of moments. The moment of a force is not just about how strong the force is, but also in which direction it causes rotation. This means the moment is a vector quantity because it has both magnitude and direction. A force can cause a rotation either clockwise or anticlockwise. This direction is crucial in defining the moment. For example, when you apply a force to a spanner to turn a bolt clockwise, you are creating a clockwise moment. When applying a force to turn the spanner in the opposite direction, you create an anticlockwise moment. The direction of the moment, clockwise or anticlockwise, depends on the direction of the applied force and the position of the pivot. In today's lesson, we delved into the concept of the turning effect of a force, also known as the moment. We began by understanding that while forces can cause objects to move in straight lines, they can also cause objects to rotate around a pivot point. This rotational effect is termed the moment of a force and is determined by both the magnitude of the applied force and the perpendicular distance from the pivot. Understanding the concept of moments enriches our comprehension of how forces contribute to the motion and balance of objects in various real-world applications. Watch the rest of the GCSE physics course at Sophos Education,